Good evening, everyone. This is a talk about the Netfarm distributed object system I've been working on. The idea is to make something that almost looks like distributed C-loss. It should just be pretty much normal Lisp, except that the objects we're dealing with are just coincidentally being synchronized across the network. No big deal. So we imagine this can be an extensible system which can support many programs on one network. So of course we have an object system in which we can define classes. You can also retrieve these classes yourself and some other metadata like a presentation program, which also can be used to describe this class without having seen it before. This should also be a multi-user system which can handle server operators and users that aren't acting in good faith. When we're dealing with distribution and distributed programs, we're looking at something that can scale pretty well. In terms of computing, obviously if you're doing it well, you can scale linearly. You can get pretty much, you can get linear speed up. Everything is accountable in the sense that everything can be reproduced, meaning it's impossible to lie about state. There's also pretty good fault tolerance. On the other hand, this accountability means that you have to be able to reproduce the state from nothing. You need something like a transaction log so that you can basically reproduce the state every single step, which is, say, for example, why blockchain uses up so much damn storage. Latency and let splits can also create temporary weird state, which you don't really want. There's also no hidden state. If you want that, then you also have to layer on an encryption or some other protocol. And updating this core protocol can also be a bit trickier. So in order to be able to bring something like this into existence, we didn't have much time, we didn't have many resources. So we decided that we'd make a completely separate distributed hash table, completely separated object system, and partly separate script machine and some other things, and then just glue them together. That went pretty well. So the first thing we made was a distributed hash table. Again, with this idea of separation, we've separated the synchronization semantics and the connection semantics, which means it's also possible to hack on those separately, which is great because you can write test systems and make sure everything's going well. This can also manage concurrent systems concurrent requests over one connection, which means that you can get better throughput. It also has a pretty fast and still very extensible reference system implementation. If you want to define a resource, such as the time, using this system protocol, you can use this define special block macro, which will define a block. You can use multiple connection types, such as this character connection and this binary connection. This is quite analogous to the grey streams. Dispatch is done using generic functions, which allows for inheritance. If one wants to subclass the timekeeping system and be able to export this time resource, they can do that. And conditions can also be communicated to the client. This can't time travel error can be reported to the user. To handle mutability in this system, we have to think a bit outside the box. I'll explain why we have to do that. But we have this idea of a script machine, which is a program system for creating portable, deterministic, and safe programs. It's based on the stack environment control dump machine, which is used for several functional language implementations, such as LispKit of yesteryear. So here's the problem: hashes don't allow for mutable data. OOP programs love mutable data. This isn't going to work. If we have a value and we change one of the slots, the hash is going to change and identity is going to be ruined. We don't want that. So what we want to do instead is we want to be able to create some kind of backreference system, which isn't going to be included in the text that makes up the hash. In this case, dealing with mutable data, we can add a backreference to the new version. Or in the case of having a circular data, we can have the forward reference being a proper slot value, and then the back reference being its own back reference. This is a bit weird, but I believe that it's probably a little bit easier to define something like a doubly linked list than in some other languages. Anyway, Netfarm nodes search for objects that affect the objects they're interested in, so they can keep track of these computed values. There's a simple message passing system which allows some degree of security and isolation. This process can also be replicated by clients because you can just retrieve the objects yourself, and at any given time the computed values are always a subset of what they should be, which is fairly not weird. It's a compromise, but it's a pretty good compromise in my opinion. So that's pretty much the whole talk. If you want some more information on this, I'm probably going to be asleep by the time this is broadcast, so we have a free node and a matrix channel. You can also retrieve the code for yourself. So thanks very much for listening. Take care, please take care, have fun, I'll see you later.